Okay, this lecture is over Module 15 of the curriculum titled IP Static Routing. So, as always, we start off with why should you take this module, and basically it's to learn about static routes and when you may want or may need to use them. What specifically will you learn in this module? We'll learn what a static route is and how to configure it. We'll talk about default static routes and how to configure that. We'll talk about floating static routes and how to configure those. And then finally, we'll learn how to configure static host routes. Um, what is a static route? It is basically a hard-coded route that we manually put into a router's routing table. There are several different types of static routes. The first they're calling a standard static route. I would call this a normal route where you have a destination address or a destination host, a subnet mask, and then an address of the next hop to send that packet to. A default static route is a route to something like an ISP, wherever we're getting our internet service from. A floating static route is basically a static route that has a higher administrative distance than any other static route and is intended to be a backup. So if our primary link fails, then it would look for the next highest administrative distance and then would find this route, which is, like I said, kind of like a backup. And then we have something called a summary static route, which is when all routes point to the same interface. So basically, we're just using one address for that all packets to travel through. The next section is called next hop options. So we have three possibilities. We have a next hop IP address that we would send the packet to. We have a directly connected static route where we say the default route or the next hop is out this interface. And then we can fully specify a static route, which is an IP address that the packet is supposed to go to, along with which interface on the router it is supposed to exit. So an IP version 4 static route, we can give either the IP address, the exit interface, or a combination of the IP address and exit interface. So we have options to the IP route command. So we can have a network address, a subnet mask, and then one of those three possibilities as far as how the packet is supposed to exit the router. For IP version 6 static routes, we use the IPv6 command. Again, you have a route, an IP address, subnet mask, which is a prefix length, and again, you can give it an IP version 6 address of the next hop. We can give it the exit interface, or we can give it both. So early on, I don't know if it was in Cisco 1 or Cisco 2 or both, we talked about dual stack topologies. And basically a dual stack topology is when you run IP version 4, and IP version 6 in the same topology. So here we have a topology, and you'll see we have IP version 4 network numbers, and we have IP version 6 network numbers. For gateways, we have the interface, and they're using the same number, it looks like, for IP version 6. So it would be 3.1 for IP version 4. For IP version 6, it would be 3::1 is how they're trying to specify this in the topology diagram. So in 15.1.5, we're talking about the IP version 4 routing tables. And what happens is when we begin, we only have local and directly connected information in our routing table. As we see here, these all have a C or an L. In the case of router 2, so going back and look, network 2 and 3 on router 1. So here's dot 2 and dot 3 are connected. In the case of router 2, which is up here, we have the dot 1 network, the 172.168.1 and the 192.168. So those are the three networks that are directly connected to router 2. And then finally, down here, router 3, we have 192.168.1.0 and we have 192.168.2.0. So this is how we start out. Now here, if we're on router 1 and we want to ping router 2, that's going to be successful because those are directly connected. Now if R1, like PC1 over here, tries to ping something on the 2.0 LAN, PC3, it's going to fail. And the reason it is going to fail is because there's no entry in router 3, or no entry for router 3 or the network served by router 3 in router 1's routing table, so the packet cannot make it to its destination. Now we kind of have the same thing for IP version 6. Here's router 1's, all directly connected stuff. Router 2, all directly connected stuff. Router 3, all directly connected stuff. And just like before, R1 and R2 are directly connected to each other. So if we try to ping from one router to the other, it is going to be successful. But we have the same thing as before. Router 1 or a device connected to router 1 cannot ping anything in what they're calling the R3 LAN, where that PC was to the right, because again, router 1 has no routing table info on how to reach router 3. 15.1.8 is a check your understanding on static routes. You can do that on your own, and we'll move on to how do we configure these static routes. So here we have what looks like the same topology as before. So here we log into router 1 and we put in a route that says if you're trying to make it to 172.16.1.0, so if you're trying to make it to the network up here, you're going to go to 172.16.2.2, which is this interface on router 2. So it'll go to this router, and then this router will know how to get it to this LAN up here. When we do that and fully populate this, notice that we have a static route to get to 172.16.1.0 and also two static routes over here to make it to the 192.168.1 network and the 192.168.2 network. So this is how we go in and configure that information and then verify that that information actually made it into the routing table. As far as the next type, static route, what it's doing here is it is configuring routes for the 1, the ACAD 1, the Cafe 1, and the Cafe 2 routes. And it is saying, so these are the routes over here. Here's the ACAD and here's the Cafe ones. And it is saying to go out ACAD 2:2. So that would be this interface here, in particular ACAD 2:2 would be the same interface that we were looking at with IP version 4 to router 2. And then doing the show IP version 6 route as opposed to show IP route shows us the version 6 routing tables, again with these 3 routes marked as static that we hard coded into the router. Now here we're going to use the interface instead of a network address and subnet mask. These are going to show up as directly connected things, as we'll see in a moment. So we're on router 1 and we're saying to get to 172.16.1.0 go out this serial link, and to make it to 192.168.1 and .2 also go out this interface. So it just sends it out this interface. Typically there's only one other thing at the end of this connection, in this case a router, which will hopefully have routing table entries to get to either of these 2. It will have these directly connected ones, but also it has information on how to get to this LAN over here on G000 on router 3. If we want to verify this, again, we can do a show IP route and use begin gateway for the filter, and it will show us those IPs. Again, they're going to show up as directly connected. For IP version 6, we basically do the same thing. If you want to make it to one of these IP version 6 networks, you're going to go out serial 0/1/0. And again, we can look at the routing table to see that those routes were entered and that they were listed as directly connected networks. In 15.2.5, we're talking about fully specified static routes. And what we do, the fully specified means we're going to tell it the next hop and the exit interface. Down here, one thing that I want to note is a lot of times between routers we have serial connections that are shown by the lightning bolt, I call it. And then over here, in this case R1 and R2 are connected via an Ethernet connection as opposed to a serial connection. So here we're saying if we want to get to 172.16.1.0 with a /24 subnet mask, we do that by going out gigabit 001, and we are looking for the destination, which is 172.16.2.2. So go out this interface, going to the IP address of this interface on router 2. And then we do the same thing for the other 2 LAN networks. Again, looking at the routing tables, we will see the static route. This time it says if you want to make it to this network, do it via this do it via this IP address, which you're going to find on gigabit 001. In the next section, we're talking about IP version 6, directly or fully specified static routes. Again, by fully specified, both the interface and the next hop IP are specified. So here they're telling us if we want to get to ACAD :1/64, which is over here on this router, we can do that by going to FE80 colon colon 2. And then what we do is here we can say, if we want to fully specify it, here it told us it was not specified that we needed to. So we really needed to say IP version 6 route destination IP address with a prefix length, go out serial 0/1/0, going to the IP version 6 IP address FE80 colon colon 2, which again is this interface on router 2. If we go through and search and say begin output when you find this string, it's going to give us this static route and tell us via this IP address over this interface. So very similar to IP version 4. Here we're talking about how do we go about verifying a static route. Again, a lot of times when we want to confirm connectivity, we use ping and trace route. We can also use the show IP route command to make sure our routing tables are correct. So here's the topology, and we're using filters in a lot of this. So display only IP version 4 static routes. So again, that's just show IP route static. And we see those for, in this case, router 1. If we want to display a specific IP version 4 network, we can say show IP route and then give a host on that network. It will figure out what network number and network mask we're talking about, and then show us the routing information associated with that. Here we're showing the running config, saying that we want to see IP route section of the running config. So here are the routes that we entered into and then saved into the running config. Likewise, we can do the same thing on IP version 6 static routes. If we want to look at a specific IP version 6 network, like we did over here on the second box, we just say show IP version 6 and give a route to a network, and it will give us the routing paths or the routing table to that. And then finally, for IP version 6, again, we can show the running config and say that we only want to see the section related to IP version 6 routes, and it will give us those 3 entries for IP version 6. So 15.2.8 is a syntax checker on some of the commands we just talked about. You can do that on your own, and we'll move on to configuring IP default static routes. So a default static route, a couple of pieces of information on that. That is a route that matches all packets. So every packet that looks at the routing table is going to be routed out the default static route. It does not require any, quote, left bits to match. If there is a more specific match that is found in the routing table, it will use that more specific route. But if not, it will use the default static route we configured. Some places, I don't know if this is in the curriculum or not, or this section of the curriculum, default static routes are often used for edge routers that are connected to your ISP. So all the packets would go out, or it may be used for stub routers. And basically what a stub router is a router that only has one upstream router. So this is a stub network, and this is the stub router. And again, there's only one connection off of that router, so we could configure that to be a static route. Now, if we want to configure a default static route, What we do is we specify the IP address and the subnet mask as being all zeros. And then we either give the IP address that we want the packets to go to, or we can give this vertical bar means or we can give the exit interface. Same thing with IP version 6. The IP version 6 equivalent address is : which substitutes for 128 zeros with a prefix length of 0. So : /0 is the IP version of 6 equivalent of this IP address and subnet mask being all zeros. And again, we can give an IP version 6 address that we would like the packet to go to, or we can simply specify the interface that we want the packet to go out. So here we have the graphic we've been looking at, and for router 1, we're saying the default static route is 172.16.2.2. So this is a stub network and a stub router, and all the packets are going to go to this IP address on router 2. And again, for IP version 6, : /0 is going to go to db8 acad2 : 2. So the same interface on router 2. To verify this static route, we can just say show IP static route, and we can look for the all zeros, or in the case of IP version 6, the : /0 in the routing tables. And again, both of these give IP addresses of where the packets should go to. 1534 is a syntax checker on the commands we just talked about to configure and verify default static routes. You can do that on your own, and we will move to floating static routes. So again, a floating static route is a backup path to a primary route, or for a primary route, in the event that we have a link failure. And again, it is created by giving what you're calling, or what you're specifying as the floating static route, a higher administrative distance than the primary route. So what happens is we learned a route from this router over to this router, and so the branch router to the headquarter routers. If that link fails, we can use a route with a higher administrative distance, which would be a backup route. 14.2 shows you how to configure these. So basically, you're going through and you are configuring the routes, and in this case, you can specify an administrative distance. So instead of the default for these links, it would use an administrative distance of 5. So we can go through and use show run and include any lines that show IP version 6 route, and it will go through and show you the routes, the primary route and the backup route. In the case of IP version 4, we say IP route static, and then look for the gateway of last resort, and then it is going to have information on that. So that's how you can go through and verify those. Now then, to test these, we have a topology here, very similar to what we have before, but there's an additional 10.10.10.0 network connecting router 1 and router 2. So basically what happens is we go into router 2, we go to interface 0/1/0, and we shut down the interface. So we're turning off this interface. And then we're going over to this router and shutting off the interface. We get messages here showing that the link is going down. And then what happens is it's going to come back and tell us that we changed it, the state to down. And now if we look at the IP routing table, it's going to show that the default route goes over this 10.10.10.0 network, or down here DB8 feed 10 network. So, if we had physical access to these, we could just unplug the serial cable or the Ethernet cable, but it's much easier just to log in and shut the interface down. That's going to simulate a failure. Uh, 15.4.4 is a syntax checker on configuring and dealing with floating static routes. So you can do that on your own. And then we'll go talk about configuring static host routes. So again, a host route is a complete host address in the routing table. That is, it is a match on all the bits, all 32 bits in the case of IP version 4, all 128 bits in the case of IP version 6. There are 3 ways that a host route can be added to a routing table. The first is automatically installed when an IP address is configured on the router. We'll discuss that in the upcoming section. Or it can be configured statically. We will talk about that as well in an upcoming one. Or it can be automatically obtained through what they're calling other methods right here. And it says this will be discussed in later courses. So we're in Cisco 2. So as far as CCNA is concerned, there used to be a Cisco 3 and a Cisco 4, as we talked about in a video the first week of class. Now there's only Cisco 1, 2, and 3. So these methods will be talked about in Cisco 3. Now here we're talking about automatically installed host routes. There's several things that we can happen. We can have a router to a local ISP. We can have a local host route. It's also known as that. It's marked in the routing table with an L. And down here in the graphic, let me find it. Okay, somewhere in here I thought it had a slash 32. So either I was wrong or I am not seeing it. But we have a slash notation for the prefix length that we can use for IP version 4. That would be a slash 32, which would input the entire IP address in the table. 15.5.3 is talking about static host routes. Here they do mention it. Basically the subnet mask is all 1. So 255, 255, 255, 255, or slash 32. And when we're talking about IP version 6, we only use the prefix length, which here is showing as a slash 128. 15.5.4 is showing us configuring these. So we have an IP address. It's a fully specified IP address to a single host because we have 255, 255, 255. 255 is the subnet mask. And the way we get there is by going to this IP address. Same thing for IP version 6. This is a global unicast address slash prefix length 128. So that is a fully specified IP address. And to get to this particular host, the routing table entry says go to ACAD:1:2. So it is fully specified. To verify that these were entered correctly, we can look at the routing tables and simply make sure that those routing entries appear in the routing table. What we can do is we can also specify a route to a machine by giving the link local address for the next hop. So here we're going in and we're taking out the route we had in there before, and now saying if you want to go to ACAD:2, in this case 238/128, so it's a specific host. You're going to do that by going out serial 0/1/0 and going to FE80:2 as the next hop IP address. You can do a show route, and here they're looking for things that have 2 colons in it. So the first line it finds with 2 colons in the output, it's going to display everything like that. The next section is a syntax checker, which you can do on your own. And then we'll move on to the module practice and quiz. So the module practice and quiz starts with a packet tracer to make sure you know how to configure static and default routes, both for IP version 4 and IP version 6. So this is packet tracer 15.6.1. I will be assigning that, so watch for that to appear in Blackboard. Right below that we have a lab with the exact same name. So this is the same as packet tracer 15.6.1. Probably will not be assigning this unless for some reason I decide to have you do it on the NetLab, which is not likely, but if I change my mind, of course it'll appear as an assignment in Blackboard. 15.6.3, what did you learn in this module? So just read through this and make sure you understand everything about static routes and default static routes that we talked about in this section. And then finally, 15.6.4 is the module quiz on the entire module, IP static routing, which you can do on your own to see how you understood information in the module. And that finishes up module 15.